Alright, I'm going to go over Firestarter 30 today. So we introduced logarithms, and we're kind of talking about some of that stuff. So the definition of a log, and a log is anything that can be written as an exponent. The biggest reason we use logs when we're trying to when we're dealing with exponents versus radicals is if the variable is in the exponent. So if you guys see how, like right here, we have I have a letter in the exponent. It'd be really hard to use it. You can't use an x root. There's no root for a variable. So that's why they had to create this idea of logs. So radicals and exponents are inverses of each other, like a square root undoes the square, a cube root undoes the cube. Logarithms are inverses of variable exponents, stuff we don't know about. So it's a way to move the variable out of the exponent. So there's a change of base formula, which is really important if we're trying to use a calculator to help us with a lot of work. That's a big idea. The other thing that we need to know, and a lot of us don't really think about this, but the other logarithm formulas that we can use are, for example, if you have a base and that same number, the base and the base of the log and the base of the exponent will cancel out. All right, that's something that happens a lot. Now, another one that's very similar to that is if we have log of the same base in the exponent, that will cancel out that way to give you just x. So that moves this x down. So this x right here is in the exponent. Now it's no longer in the exponent. This x right here is in the exponent, no longer in the exponent. Another one we'll use a lot is that if you have base e, you don't write it as base e. This is called a natural log. Alright, and there's a bunch of math behind that as well. But this is really important too because that's in my calculator. So I can use my calculator whenever I see that. Alright? And then you can use other things like that there's a bunch more complicated properties we'll probably talk about, but that's kind of good for today's Firestarter. So, number one, evaluate log base 4 of 4 to the 7th. Those cancel, so this is just equal to 7. I didn't have to use my calculator at all. Alright. Number 2, this is automatically base 10. If no base is written, then base 10. It's why your calculator doesn't have the little 10 on it when it has the log. So really, all I'm going to do in my calculator is I'm going to plug this into my calculator. Now, it's really important that you understand that I need to put that in parentheses, right? Because it's slightly different any other way. All right. So I plugged in my calculator. So really, I could do two things. I could plug it in my calculator, parentheses 5 squared. All right. That's different if the 2 was outside. If the 2 is outside those parentheses, then you're squaring it at the end. So you could put 25 in there. You end up with 1.398, and so you're going to get about log base 10. We'll say 25 here. We'll say 5 squared equals 1.398, and it's about. Now there's another interesting formula that helps us here. Since this 2, another thing that you could do is you could take this 2 and you move it out front. That sometimes is really helpful. So there is a formula that looks like this that says if I have log, doesn't matter the base, I have x, y, I can take that little y, I can move it out front. So I could have rewrote this as 2 log, and remember, you don't have to write that 10 there, base 5, or log 5. And we're going to come back to this idea probably later in the week. So, alright, so numbers 3 and 4. Once again, so number 3 is kind of like what we just talked about. I just wanted you guys to see that when I plug this in, so I'm going to plug that into my calculator. So I'm going to press 2 log of 5, and I end up with the same thing I got before, which is 1.39, and it's about 8. Alright, so the interesting part, remember this is a base 10 here, is using this is basically saying, if you want to see if this kind of makes sense, so I can use this right here to kind of check my work a little bit. Now notice there's nothing in front of this, so what I would do first is I'm going to divide everything by 2, just like we're solving. So I'm going to do so I end up with that. So I get log base 10, 5, and it's about 0.6989, so we'll say 0.60.699. So by this definition, a good way to kind of see how our work is this is the base, so that's B, it's the same B that's there. So I could say that 10, and then I have Y, that's Y, so it should be equal to 5, and then X is here, that means this is X, so that should be my exponent. So if I wanted to see if my work's correct, I could always put 10 exponent 0.699, and it gets really, really close. So if I didn't use the estimate, it'd be there. I could also done it similar to the last page, where instead of using divide everything by 2, I could use 25. So that's an option as well. Number 4, very easy, because remember ln is the same thing as log of base e to the 7th, so they cancel. So ln and e cancel, so this whole thing is just equal to 7. And that's it for 4. And number 5, so remember, if you plug that in your calculator, I want you to make sure you put that in parentheses. Here's your calculator, does it for you. So I'm going to put ln, that's a button on your calculator, 5 caret 3, hit enter. So remember, this is an about. I end up with 4.828, so we'll say 4.828. Alright, 6, exact same thing, I can use the calculator, but this time I'm going to type it in, 3 ln of 5, so I end up with the same exact thing, 4.828. So what I'm trying to illustrate is this formula right here, is that if you have this little y, it can move out in front, and they're the same exact thing. That's going to be important when we go to solve, because the whole point of this is to get the letters out of the exponents. So we don't want to have more exponents than we need to. So it's actually going to be a very useful formula when we go to solve. Alright, so last one we're going to do is this. It's just calculator work. Alright, so I can't do this in my calculator because the base is not 10. Alright, so this is a really good way to make it so we can use our calculator. You're allowed to make whatever base you want, as long as you write it this way. So I just did the log of base 10 with 6, then the log of base 10 with 4. Right? I like to do that. So I put log of 6, basically, I put log of 6 in my calculator, and then divide it by log of 4. I end up with about 1.292. Now, some people don't use the log. Some people like to use ln. Same difference. Look, if I plug it into my calculator and I use ln of 6 over ln of 4, I'll get the same answer. ln of 6 divided by ln of 4, I end up with the same exact answer. I could have, if I wanted to, wrote it as log of base 6 over 6 over log of base 6 over 4. Now, I don't think that'd be very helpful because I don't know how to do log of 6 in my head. It would cancel the top, but it's not going to be helpful. So I wouldn't do that, but you could. All right, maybe your calculator only did log of base 6. All right, so number 8, really easy. Log, I'm making a base 10. You only have to write that little 10 if you don't want to, over a log of base 10 of 3. that's going to be equal to, in my calculator, just put log base 7. Remember, you're not plugging that 10 in, especially when you use the calculator. Log of 3, you end up with, and remember it's about, it's not exact because we're estimating 1.771. Like I said, if you don't like that, you could always use the ln, where you could do ln of 7 over ln of 3. Alright? And just to double check, I put ln of 7 divided by ln of 3. It gives me the same exact answer. So that works. So that's it.